All right, so we're going to go back through this thing, and we're going to kick up with our where we left off on the chemical application, and I believe we left off here on the pump selection. So some of the things that we talked about with the pumps, right? You got to make sure that you know that you have sufficient capacity, so the pump's got to be able to supply the boom that you have. So it depends on, what your output is, how big your boom is, what type of nozzles you have on. That pump needs to be able to withstand or allow enough pressure for these nozzles to do what we want. And when we're in lab, probably the next couple of weeks, we're going to kind of talk a little bit more about nozzles, because that's really kind of the biggest thing with a lot of these pumps. We're going to go through some systems, and you may have already seen this by the time we have lab, but hopefully these things kind of correlate with each other. The pumps obviously have to be able to resist corrosion and wear. You've got to be able to replace them if you need to. They really are kind of the heart of everything, and if the pump fails, none of the rest of the system is going to work. So it's really important that we have the availability to fix it, to repair it, or to replace it if necessary. What type of drive, what type of coupling do we have? How is that stuff going to be powered? There are lots of different ways that we can do that. You're going to see two examples in our lab this week. We're not going to worry too much about the pump power with the horsepower and all that kind of stuff. We'll kind of deal with some of these equations a little bit later. Right now, I don't want to worry you guys with that. So we do have a couple different types, right? We talk about metering pumps. These are going to be pumps that are driven by a wheel that's going to be on the ground. And as that wheel turns, it's basically going to, increase the pressure or decrease the pressure. So you can run through a field fairly quickly. It's going to increase that pressure. So that way we have the output that we want, and we're applying the correct amount of chemicals on the field that we are desired. If we slow that stuff down, it's going to slow the chemicals down. That's kind of one of the bigger issues that we deal with when we're spraying is, when we stop, or if we slow down, if we, run into an obstacle in the road, we have to shut the valves off. We got to make sure that we still get that coverage. And with some of these things, it does become, a big deal, and we could potentially waste chemicals or not make the application. So a metering pump where you have a driven ground wheel is going to be, great. You can have a variable stroke piston. You can have a hose pump. Either one of those things are going to work. You might see some of those examples, and we'll talk a little bit about that stuff as we look at the actual equipment. Pressure pumps, or not pressure pumps, sorry, but pressure is going to be regulated not just with the pump, because the pump, depending on how we have that, whether it's a PTO, whether it's an engine driven, they're going to be, they're going to be increasing or decreasing their pressure depending on the RPMs of the tractor or the RPMs of the engine that we're using. But to really fine tune these, the pressures that we're actually delivering at the nozzles, we're going to use regulators. Regulators are the best way for us to adjust this. You can see an example up in the top right there where we have a regulator that we can adjust the nozzle up, we can adjust that nozzle down, and we can really fine tune and pinpoint the correct pressure depending on the RPMs of the engine or the tractor that we're actually running to. How some of these pumps or how some of these regulators are ran and how they kind of work within the system is going to be dependent on the type of pump that we have. Sometimes we have to have, if we reduce that pressure, we have to have a diversion where it's going to revert back. That way we don't increase pressure and blow lines. Sometimes we can completely shut things off if it's a non-positive displacement pump, which we've already kind of talked about, but I'm going to show you guys some examples in lab again that kind of show you that, and we'll try to dive into those things a little bit more. A lot of times we do, if we have a positive pressure pump, which most sprayers, do have those, it really kind of depends on what we have. They have a regulator that if it reaches over and it has too much pressure because we're trying to tighten it down too much on our regulator here, it's going to allow that stuff to kind of flow in a different direction. So that way we're not going to damage the valve, or we're not going to damage any of the equipment on there. Gauges are incredibly important. When we are making applications, we get requisitions that are going to tell us we have to apply so much of the chemical, so much gallons per minute or gallons per acre on that field, and we have to make sure that we are maintaining that application as closely as possible. And so using the regulator and using the pressure on that regulator, we can then go into the valves and or into the nozzles, and we can determine what is going to be our output per nozzle, and then how many nozzles do we have on the spray rig. And that's where a lot of this kind of calculations and the different stuff that we're going to get into in the next couple of weeks, we're really going to kind of dive into it. It's really not that complicated. I'm going to give you the equations, and when we get tested on these equations, you're going to have the equations that you're going to use. I don't expect you to memorize the equations. You're going to be able to use those things, on tests, on quizzes, because I don't want you to memorize them. I want you to understand how to plug things in. And one of the biggest things when we get into those applications and into the numbers and stuff like that, it's really the conversions that really screw people up. It's not the the equation itself. That's why I give you the equation. Okay, you can have that and you still might mess it up because you don't convert a gallons per minute to ounces per minute, or if we're doing seconds, you don't convert that into minutes. You don't convert the seconds to minutes, so on and so forth. So but the regulators are really going to help us. The gauges are going to help us identify where we're at, so that way we know what our actual output is. Sometimes we have issues in these systems with like the strainers, okay, and these things are going to get clogged up. It's not going to allow the flow out of the nozzle. And so that's why when we do a system check on these things before we spray, we don't have to do it all the time, but we do it every once in a while. But these strainers, these things are going to get clogged up, and it's not going to allow that flow, and you're not going to get the flow rate that you need. You're not going to be applying the chemical in the rate that you need. And if it's like a herbicide, it's not going to do its job. If it's a pesticide, it's going to be the same thing. We do have a couple different regulators. We have tank ones, which you can see kind of right here, which is a main line. Any kind of foreign material, or any kind of, even the chemical, sometimes if we use like a dry chemical and we're mixing it in, if we don't do a good job of mixing it and agitating it, it's going to clog up these screens. You're not going to have that flow coming in. At each of the nozzles, we have a filter as well. And I think I've got some pictures that I'm going to show you of the ones that we went out and on the spray rigs for lab. And you can see that those things are clogged. We have to regularly clean them. We have to regularly check them to make sure that we don't have any obstructions there. But what it does do is it protects the nozzles from getting clogged up. They're easy to clean the filters or these strainers off, but it's just one of those checks that we have to do as we're setting up these fields. But once we, once we set it up and we kind of test it, we make sure that we're getting the output and everything that we want. We can determine, if we have the correct GPM. If we don't, we can, adjust the pressures up. We can adjust it down to really kind of fine tune to make sure that we're getting everything that we need. So again, these filters kind of do the small pipes. They kind of get the small particles and stuff, keep them from getting into the real fine nozzles and the different parts that we have there. Obviously, there's pipes, there's hoses. Those things are going to take the liquid from the pump to the nozzles, and maybe even back to the tank. That's what's going to kind of direct everything and put it where we want. Kind of following these lines and understanding your spray rig is really a big deal, and understanding how that stuff flows. And we're going to talk about that again on 2 spray rigs that we're going to kind of look at. You really got to worry about kind of 2 sides. One is going to be your suction side. That's going to be before the pump. And the other one is going to be after the pump, which is your pressure side. They've got to be able to withstand the pressures that you're creating. If you have a high pressure pump, you got to have, clamps, you got to have, different things that are going to be in place that's going to be able to withstand those pressures. You can't just buy a cheap pipe that maybe isn't going to hold that. Understanding how much your output is, what your PSI on your pump is going to be relevant to the hoses that you have. Most of the time, you're going to be buying, a spray rig as whole. You're not going to be building it from scratch, but we do have to repair. We do have to replace things because hoses are going to get cracked, especially if it's left out in the sun, and you may have to replace those things. You're going to have to replace nozzles. You're going to have to do all that kind of stuff to maintain these spray rigs so that way they're operating at their peak efficiency. Obviously, the hoses have to be resistant to the chemicals. Some chemicals we have can be very, very corrosive. And just like the tanks, just like the pumps, all the hose lines have to be resistant to that corrosion as well. Frames are going to vary on spray rigs from spray rig to spray rig. Some of them are going to have an axle and tires. Some of them are going to hook up to 3-point. Some of them are going to be attached directly to the tractor. But they have to be strong enough to hold that. When you think about, some tanks, if you have a tank that's, 200 gallons, liquid weighs roughly about 8.5 pounds per gallon. So you could have, something that is, if it's a 200 gallon tank, you could have something that weighs, over 1,000 pounds. that is, that frame needs to be able to withstand that. It can't be a lightweight frame. So depending on the size of the tank, depending on what you have, that frame has to be able to withstand that. If it's a 3-point, that tractor's got to be heavy enough so that way it doesn't overweigh that tractor and flip those things over. Things got to be balanced, right? And you got to have space to attach any kind of booms or different things. Really depends on what you want. There's a lot of different options. What we're going to show you is just kind of scratching the surface, but the basic components are there in every kind of spray rig. That doesn't really change from one to the other. You got to have a way as the operator to control these valves. Some of them are going to be electronic. Some of them are just going to be a manual where the hoses actually come up to the tractor and then they return back. Depending on what system we have, it really depends on what we have, but you got to be able to control from the operator seat, turning the nozzles on and off. When we get to the ends of rows, maybe sometimes we want to turn one side off versus the other. And so we set these things up to be able to have the ability to control when these things come on, when these things come off. Again, in lab, you're going to see, some of those examples on how we do that. So manually, electronically, really are the two basic ways that we're going to do that. And sometimes, depending on the system, you might be able to just shut it all off at once or all on, or you might have the capability of shutting, each, set of nozzles off to kind of, hit certain areas. Now the nozzles, you can see kind of in this little picture right here, there's a lot of different nozzles that we have that are available to us. If you look, T-Jet is probably the most common one that you will see. If you go pretty much anywhere, T-Jet nozzles are like the industry standard. And there are a ton of different nozzles for different applications, depending on what you want to do. These things are really going to do three things, right? They're going to meter the liquids. They're going to atomize that liquid into droplets. So we actually, on a lot of these are going to infuse water to make these droplets a little bit bigger and a little bit more resistant to any kind of drift. Drift is probably one of the biggest issues that we have when we are spraying. We want to make sure that we're applying chemicals directly where we want and not to places that we are not. We want to make sure that we drop those, liquids in a specific pattern. So sometimes we might just be, spraying a strip. Sometimes we might be spraying a whole field. Really depends on the application, what we're looking for. If you think about like almonds, a lot of times when we're spraying in almonds, we leave a center row of grass for beneficial bugs to help retain moisture, but the berms we typically are going to spray out. So we don't spray the middles, we spray the berms. If we're doing a fertilizer application in like an alfalfa field, we're probably just going to drive it over. We're going to have that boom, the full length of it. We're going to have a lot of nozzles, a lot of output, but we're going to be able to, get that stuff applied pretty quickly. The flow rate is going to depend. Each set of nozzles has another set of nozzles in there that's going to change the flow rate. Essentially, the orifice on the inside that's going to allow that liquid to flow through is going to change in size. And so identifying that size, knowing what size, knowing the output, depending on the PSI, is all going to be kind of critical when you're selecting nozzles. A lot of times things are set up, you kind of set it up, you really don't have to mess with it too much. You're not changing these things out all the time because we typically have spray rigs that we utilize for the same application over and over again. The one thing that you need to realize is as the flow rate increases and as pressure increases, it is not going to be proportional, okay? So just because you double the pressure up doesn't mean you're going to double the flow. The orifice size really has an idea, and there's going to be some charts that we're going to see that are going to tell you everything that you need to know. They have tons of tests, tons of information that you can utilize as a good gauge, and they're fairly accurate. They're pretty accurate when you set these things up and you set your PSIs up on these nozzles. So you're going to see some of those sheets. And we're going to kind of go over those, teach you how to read them, teach you how to go through them, how to find the information that you need. So those tables, like I said, right, the tables are from the manufacturer. Like I said, T-Jet is the most common one that you're going to see that's going to be out there. And depending on the pressure that you have, there are charts that are going to tell you if you're at 40 PSI, it's going to have this much output for this specific nozzle. If it's 60 PSI, it's going to have this much output for this nozzle. And so you use those things as a baseline when you're calibrating your spray rig to make sure that you got the right flow rate. The atomization, okay, it really helps break those things up. It really helps get those droplets down into the ground. We don't really typically want a real fine mist, although in some applications we do. But if we're doing like a herbicide application, we're just trying to spray some weeds, we typically want a bigger droplet. If we're doing kind of tree spray applications, we want a real kind of fine mist powder. And so we have real high PSIs that are going to really kind of blow that stuff up and let it get carried up into the air. But on those days, we got to watch, really in any day, we got to watch what our wind is. We can't really be spraying with a lot of wind because that wind will take these droplets and move them into an area that we do not want that application to go into. But we can adjust those things. The nozzles have charts. They tell you what the droplet size is. So if you know you want to fine, medium, or coarse, you can adjust your nozzle based on your application that you will want to do. This is an example of one of the sheets in lab and different things. I'm going to show you some different ones because there are specific sheets for the nozzles. But you can see these nozzles are typically color-coded for the amount of output that we have. And so if you look at the color code, you'll be able to see that and you say, okay, I have, the AIXR 11003. We'll talk about what that stuff means, but you can see we've got different PSIs here. You can see what your capacity in one nozzle is per GPM. You can see what it is in ounces. You can even kind of determine what your gallons per acre are going to be if you have a very specific kind of miles per hour. So if you're running 4 miles per hour, and let's say you're running at 40 PSI, you're going to have an output of 22 gallons per acre with those nozzles if you're running it at 4 PSI and all that kind of stuff. So these charts are really nice. There's a ton of information. Some of it we're not even going to really mess with. Sometimes we might just be looking at what our output is right on that side right there. And again, we'll talk about what those numbers mean. I'll do that more specifically. It's better to do that in person or in a live thing than on a recorded stuff. But just an example of what the charts look like. We'll kind of deal with that a little bit more. When we talk about droplet sizes, they are measured in microns, right? So your average droplet size is affected by your nozzle type, your size, how much pressure you have in your system, what kind of liquid do you have? Is it a little bit thicker liquid or is it a little bit thinner? Some of the stuff that we apply with these chemicals, you might have like a dry powder that we actually mix into it. It might make it a little bit thicker. If you don't have as much water and you have more of those chemicals, that's going to change those things. So your droplet size is really going to kind of depend on what you have. As we increase the pressure, we're going to decrease the droplet size, okay? So the more pressure, the more that it kind of sprays. You can kind of think of this like if you have water in your mouth, right? Let's say you have water and you want to kind of spit that water out. If you kind of tighten your lips up and you blow real hard, you're going to kind of create a nice fine mist versus if you just kind of like open your mouth and just kind of push it all out, it's just going to kind of come out. It's going to have bigger droplet sizes as opposed to creating a mist. I'm sure most of you have probably done that at one point in your life. If you haven't, try it and you can see what it looks like. Just be careful, you might get water all over you. But as we increase the pressure, we're going to decrease that droplet size and you're going to create more of a mist that's going to have the ability to be carried with drift or with wind, which you may or may not want depending on your application. There are lots of different patterns when we deal with nozzles. The 5 most common patterns that we're going to be dealing with is a hollow cone, a solid cone, a flat, an even, and a flooding. Depending on our application, depends on which one you want. That's why there's a ton of different nozzles. There's a ton of different, sizes and, shapes and what they want to do, what they want to accomplish. We're going to talk a little bit about some of these ones to kind of show you kind of what they look like. So we've got hollow cone, we've got solid cone. This is kind of what the spray looks like on these things. When you've got a full cone, it is kind of making a nice kind of round circle. This is the droplet that's going. When you got the hollow cone, you have the center portion that is actually not getting anything. You're going to kind of reduce a little bit of your, application. But typically we use these things if we're spraying fungicides, insecticides. We might have them on handguns when you need kind of have a high output, especially on a full cone. You're going to get a real high output and you're going to apply a lot of chemicals. The ranges or the degrees that the spray nozzles can come out are going to range from 30 to 120 degrees typically on these ones. So you're really looking at these ones, fungicides, insecticides, that's probably the most important. Flat nozzles, these you typically are going to have when you have broadcast applications, fertilizers, insecticides, herbicides. So if you're, trying to, get rid of weeds and different things like that, you want a uniform coverage across a nice swath or a nice width that you're going to make. The flat stuff, you'll notice that they tend to kind of taper out at the ends. We typically are going to overlap these nozzles. So one nozzle is going to be spraying, the next nozzle is going to overlap this one a little bit to make sure that we get a good complete coverage. As we pass by, hey, we're not putting as much material down, but you're getting a nice, even, uniform layer that's going to cover the whole field. These are probably the most typical ones that you're going to see for a lot of different applications for what we have. Even spray nozzles, these ones, you can see that they don't kind of taper out like the flat spray ones there. So if you want to just have like a nice kind of width where you're just making one pass and you don't want these things to be next to each other, you're going to use these even spray nozzles. So there's a sharp cutoff on those edges to make a nice sharp line. If you want to do this like with planting equipment, if you are wanting to put a fertilizer, but you don't really want to spread that fertilizer out where that whole field's at, you really want to kind of pinpoint that, and you want to put that fertilizer right where the planting is going to be. That's typically where you're going to see these even spray nozzles. Flood nozzles are going to put out, they're going to have a very wide range, a very wide degree. They're going to have really large droplets. They're going to have a high output. You're going to use these when you want to do a broadcast application of fertilizers, defoliants. If we want to, like on cotton, we have to actually spray a defoliant to get the leaves to drop before we harvest the cotton. These flood spray nozzles are really what we're going to use to accomplish that. And there's different positions, there's different patterns, there's a lot of different things that we can do, but it's going to have a high output, it's going to have large droplet sizes, and we're going to go from there. So lab, we're going to kind of talk about some more of this stuff, and probably the next couple of weeks, we're going to start getting you into the chemicals and running through the numbers and doing sprayer calibration. So I will see you guys later. Thank you.